Enjoy. A round of applause for Nanook and Carson and Sivo and all the other guys that are holding this down, really providing an amazing service. Having to suffer through all the Bitcoin talks and Monero, it's got to be painful, right? Just kidding. We could do this all day. So this talk is about, it's not really a talk, it's an AMA, so we need a lot of, interaction with you guys. So don't be shy. I'm going to run around with the mic and hear what you have to say, and we want to answer your questions. We have some of the biggest experts in Ethereum on stage right here. It's pretty cool, so take advantage of it. I'm going to give a quick 2-minute introduction to what Ethereum is. Just in case there are a couple people who don't really know. The first cryptocurrency was Bitcoin, and it does an incredible job at moving money around in a transparent way. And Ethereum does the same with lines of code effectively. It's kind of the goal of Ethereum is to be the decentralized world computer. So the idea is there's one computer that anyone can put an application on, and then anyone in the world can interact with that application. Now there's a lot of technicalities to pulling this off, but that's the quick 10-second intro. Let's go straight into introductions with these guys. So this is Jordi Bellina. Jordi, say something about yourself.
Well, just some. Mainly, I'm an Ethereum fan. I'm a Solidity dev, and I did a lot of things in the last 2 years in Ethereum. Some of them writing some smart contracts, doing a lot of audits for many of the contracts, and white hacking also some contracts, and a lot of stuff. I'm very excited in what's going to happen in the upcoming years in the space.
Hi, I'm Christian Reitwiesner. I discovered the Ethereum project in summer 2014 and joined as a full-time developer also around that time. And I created the Solidity programming language around then, and this is also still my main focus of work there. But I also work on research questions on the topic of privacy, CK snarks, interactive verification of computations, so scaling solutions and other things.
I'm Afri. I'm quite active in the Ethereum community for several years now, and most recently joined Parity as community manager.
Hi, I'm Vlad. I've been working on Ethereum. I mean, maybe I got involved volunteering April 2014, and I started working on proof of stake September 2014, and that's still what I do. And I'm also working on sharding and a few other side projects.
Okay, I'm going to talk these guys up a little bit more. So Jordi is one of the most prolific hackers in the space. He rescued 10% of all, or protected 10% of all Ethereum in existence with the DAO when that happened, and then helped give all of the, when it became ETC, gave all that back to all the DAO token holders. And then also when the Parity hack happened, he and the Giveth team flew into action to protect $210 million worth of Ethereum. And he develops incredible apps, especially for Giveth, but also Mini-Me token contract, and he's pushing another token standard. So as far as dApp development, this is a great opportunity to ask Jordi about that. Like Christian said, he is the man who created Solidity, the programming language. So anything about that, this morning on the train he added error messages. Okay, this guy is incredible.
I started 2 days ago on the train, but it was developed on the train between Berlin and Leipzig.
Yeah, in 2 days. I mean, the guys, and also one of the few people who understands ZK snarks in the world. Okay, so go wild. Afri is on the front line, community manager for Parity. That is an exciting adventure. So, and he also moderates the Reddit and is really just all over the community space. So if you have any community questions, he's the man. And then Vlad is scaling, scaling, proof of stake. Also really interesting on governance protocols and governance strategies in general. So lots of opportunity for questions. And who wants it? Who wants first crack at it? Oh, come on. There it is.
Hello, thank you very much for coming. So I have a question about these smart contracts on Ethereum. So I can see how they kind of work inside of the chain, but let's say I want to tie them to some real world event, making maybe a wager with someone, or selling some product that kind of he has to confirm that it really happened. How can they kind of tie to the real world event? Do we need certain people observing the real world and then say, okay, this happened, so we also tell the chain, yes, it happened? Or how does it tie to the real world?
I can, yeah. So basically, we generally refer to these things that provide data about outside things into the chain as oracles, and there's a whole problem of how to secure these data feeds and make sure that you're not being lied to as a smart contract about the outside world.
There is an interesting idea there. It's future markets. That's very related to what an oracle is. It's a kind of betting that something really happened for something that's real. That's a way of introducing decentralized oracles, a way to do on that, and there's a lot of stuff that's working on there. But that's one of the ways to put data in a decentralized way.
I mean, perhaps, so that's a very good question, because it's a tough one and there's no real solution to this problem yet, I would say. But so this is not I would say this is not the main focus of applications on Ethereum. So you don't need that if you just have interactions with two people, because these two people, they can interact with the system, giving their personal opinion about the state of the world. And if they disagree, then you have to kind of moderate. Or if you already have a digitized system with digital signatures and hashes, like, I don't know, a file sharing system, then you can put Ethereum on top of that to provide a layer of incentivization to, for example, when you have a BitTorrent network, then people don't provide files if they are not interested in these files. So you could use Ethereum to pay people to hold on to the files that you like. And it's really easy there, because everything is already digital, and you don't need this interface to the real non-digital world.
Sorry, but in terms of like what the kind of classes of solutions are, there's basically, you can have like a single trusted oracle, and you can try to make it as really trusted by like using secure hardware, or making it someone with reputation, like, you know, maybe Reuters or Bloomberg will provide a data feed, or like maybe you can provide it yourself. And then there's like these incentivized solutions that don't really have oracles, like kind of Jordi was talking about. And then there's things kind of where you have oracles that have reputation systems, but not just financial incentives. So the design space for oracles and securing them is, I would say, still hasn't provided like any like silver bullet solutions, and I'm not sure that like there will ever be one. You know, so the blockchain, like, it's like this amazing autonomous thing, but if it wants to interact with the world, you may need to like put some data in there.
Just let me give you two examples of oracles that are running right now in the space. One of those is a price oracle that's running right now in the MakerDAO, in the stable coin that they are doing. It's a federated oracle, so there is like a 10 trusted source, and mainly there is a smart contract that what does is do the median of the prices. So if there is one or two that are just far away, or they are trying to trick the system, it's not going to work. That's one of the examples that's going on. And the other is the one that wants to implement Gnosis, and it's mainly it's a centralized oracle who decides, but then the rest, so a lot of the people can bet the oracle, can say, okay, the oracle is bad, and then starts like another procedure. It's a more decentralized procedure where there is another kind of voting and a more decentralized system. These are two examples that the people is working right now in the space about oracles.
Hey, I have a question that relates to security. So, looking back at decades of security breaches and exploits, there's a growing realization in the security and software industry that the only viable way to have some degree of security is simplicity. Okay, sorry. So to build simple systems and simple components that can be verified and then maybe combined in a secure way. So when I look at Solidity, I was taken aback by the complexity and of the size of the language. And judging by the exploits we had, the DAO, parity twice, etc., it would appear that it's almost impossible to write really good secure code in Solidity. Are there any plans to introduce something, a pin down, button down, simpler language that can be maybe verified and that could be used to write like high profile smart contracts with a lot of money riding on them on the blockchain, Ethereum?
First of all, of course, there is a balance that this happens in always, especially in IT, a balance between functionality and security. Okay, and it's a balance. If you get a lot of functionality, things get more complex, and it's more easy to not work. And also mention that 100% guarantee that something is safe, you never have it. So it's the security is something that has a measure. So depending on the application, your optimal place is in one side or in the other, or in the other side, or you somewhere in the middle. And smart contracts, I would not say that's impossible to write secure smart contracts. There are a lot of smart contracts that are working and that they're working okay, and at least until now looks okay. Of course, it's a very, very, very young technology. We are still learning how to write these smart contracts. I'm sure that Christian has a lot to talk about the Solidity and about the improvements that has been in the language in order to improve security. But if you try to do some of the functionality, some of the smart contracts that are doing that can be done in Ethereum, it's impossible to do in other technologies that's not in Ethereum. So
yeah, I'm not sure where I should start, but so first, Solidity is not the only language for Ethereum. There are multiple languages with various degrees of complexity. You could program the whole thing in EVM assembly, which is an extremely simple language, but I would say that the fact that it's extremely simple doesn't mean that it's easier to write correct smart contracts in, because it's extremely low level. And then the other factor that you have to take into account is the Ethereum running programs on Ethereum is extremely expensive. So the final bytecode has to be cheap, and I would say this already rules out many languages that have a complex runtime. So, for example, garbage collection is something that is not really practical on Ethereum. And then so these are some reasons why Solidity is built the way it is built. Having said that, we are reducing a lot of complexity as of lately. But so there are also so you can programming it directly in assembly. Over the last several months, we also created a new language called Julia, which is more or less EVM assembly plus function calls, loops, and variables. And I would say this is an extremely simple language. It has also been formally specified. And the idea there is also it allows to provide to compile into several backends. So it also makes it future compatible with a switch to a WebAssembly-based virtual machine. And it will also be a future intermediate language for Solidity. So Solidity compiles to Julia, Julia compiles to EVM. And then there's also Viper, which is has Pythonic syntax and has the special feature that it always has an upper bound on the gas costs for each function. So it doesn't provide unbounded loops, for example, which is also a measure of simplicity of a language. I'm not sure if that qualifies for being able to write secure smart contracts. Yeah. Someone else?
I got a
Does that answer that question?
I got a follow-up question from the crowd. When is Solidity 1.0?
When the community feels that it's ready.
Okay, there it is. Any other questions? You're good.
Hi, thanks for doing the AMA. I was wondering, with increasing interest by corporations in Ethereum, what do you think is the long-term perspective? Will corporations use the public Ethereum blockchain, or will they develop something similar and use it within their corporations and not use the public world computer?
Yeah. So the question is like, how will corporations use the public blockchain, or will they end up using like their own private blockchains, or like something connected to the public blockchain?
Private blockchains are a very, very interesting technology. I think that it's a technology that can be used in the corporations, and it can be a breakthrough. It's like APIs standardize the way the corporations talk to each other, but a blockchain, a private blockchain, can like formalize. It's like the log, everything that's happened, and this is a very cool technology. But personally, this is just a good technology. Blockchain is something that can really change the world, and this happens in the public blockchains, not in the private blockchain. So at least in my side, I'm more interested in the public blockchains, where everybody can use it and you can change socially and where the things can happen. But of course, this technology is very good for the corporations and for private technologies, and can work very good.
But I do think that, I mean, I totally agree. I mean, I think private blockchains kind of suck and are boring. But you know, from a tech point of view, okay, they're kind of interesting as a distributed system. But I think that there's a really big opportunity for corporations and institutions and to use the public blockchain, actually, because the public blockchain represents kind of neutral ground outside your jurisdiction that you can operate and access from your jurisdiction. It's kind of like digital international waters. It's somewhere you can put rules that are going to be enforced and trusted by people who don't believe in the legal system in your jurisdiction. It can let you access customers that you wouldn't otherwise be able to reach. It can let you operate in jurisdictions that you otherwise would be banned from. These aren't necessarily uniformly positive things, but I'm sure that there's going to be lots of use cases for corporates, for institutions, for private associations, for all sorts of organizations to use the public blockchain, because the cool thing about the public blockchain is that it exists outside of, for many intents and purposes, your jurisdiction.
Afri, I know Parity does a lot of enterprise solutions, right? Can you talk about that a little bit?
I kind of agree. Private blockchains are boring, but in the case of Ethereum or companies using a private or permissioned Ethereum or EVM-based blockchains shows that this is technology that's important, that's actually has a use case, and companies are using it, and that's just paving the way to use the public Ethereum blockchain for like enterprise applications. And in most cases, you have limitations using the public blockchains due to scalability reasons. For example, if you have, or if you just want to save money on transaction fees, and I think maybe we'll talk about scalability later. I think the future will be that there are a lot of blockchains, a huge ecosystem of private, permissioned, and public blockchains that at some point will work together as a whole heterogeneous system of chains. And the future will be building bridges between them.
That's good. Oh, hey.
Hello, could you name me a use case for private blockchain? I can't imagine it being an advantage over a usual database.
Yeah, it's right now. If you see the quantity of money that's spent just verifying that a normal connection between companies matches, and who is responsible of if I send you the good data, you send me the bad data, you just follow that protocol, you don't follow that protocol. All these communications that happen between companies, if you put that information in a blockchain, public or private, but you put in a blockchain, which is a unique source of truth, it's like this is like the main source. This is and this can save a lot of verification time between and problems, checking the logs from one side, the logs from the other. If you manipulate the logs, you don't manipulate the logs, and this is very, very, very interesting. I think that all the communications that happen between companies will end up at some point in a blockchain. And imagine the quantity of information that's going on between companies, entities, and corporations in the society.
From like a more distributed systems point of view, a blockchain is a consensus protocol, which is like a database on steroids. I mean, it can replicate and like more interesting data structures than is possible with just a database.
Hi, this is, I think, following up a little bit on the questions about programming for Ethereum. I'm not very knowledgeable about how you program for Ethereum, but my understanding is that when you write programs, they can have bugs, and those bugs can result in things not going the way you wanted and possibly losing a lot of money. And so I'm curious, specifically on the axis of, when you write a program for Ethereum, how can you make sure that what you've written actually expresses what you want? Doesn't have a bug or a security flaw in it? Or when you read a program that someone has written for Ethereum, someone shows it to you and you want to audit it, how do you know when you read it that it actually does the thing that it's supposed to do? I'm curious, if you had to start over and design Solidity again, what you would do differently if you wanted to improve it along that axis, and if you could name a criterion by which you would consider it a language successful. Like, at what point you would feel like, okay, I've now achieved a language that I think is sufficiently easy to understand and sufficiently easy to read and write.
Well, first, I would say that most. Well, you would. Yeah. First, I need to say that I've been auditing many contracts, and I tell you that lots of the bugs that we found in these smart contracts were not in the code itself, were more in the specification itself. So formal verification and language and all that stuff is not a warranty. It's not the only thing that makes a contract secure. How you do it, you will never have the warranty assist, because even formal verification that gives you this mathematical, maybe the definition is bad. So even that you cannot guarantee that way. And then it's just a matter of trying to get as better as you can. And the way is just auditing a lot, running bug bounties a lot, having very good depths, watching a need, doing simple code, just following the best standards that we are learning and improving every day.
Yeah, I guess my question is, you have a lot of experience doing this now. You have experience as a language designer. You have experience writing contracts. And I'm just curious, what have we learned from all this experience?
If you go to, there is a page, I think it's in somewhere in the consensus repository, where there is like a full list of examples and different Ethereums and different bugs. It's the best practices, I think it's called, on Solidity. And it's huge list. Just reading that list is enormous list. Just reading there, you will see how much we learn, in the last 2 years. And that, I tell you, it's a lot. Almost every project that it's in the space will learn something from any of the project.
And there was part 2 of that question, right? If you had to redesign Solidity again, what would you do differently?
Yeah, so I mean, most of the other questions, they are not specific to Solidity or blockchains. This is just so you can be sure that a program, I mean, you can never be sure that a program does what you think it does. You can not even be sure that what you think it does is actually what you think it does, because you might not think about all the cases. And I think a good way to get close to that point is just to provide as many different perspectives on a program as possible. And this means one perspective is the code itself, another perspective is running test cases, and a third perspective is a formal specification, and another perspective is internal assertions in the program, and so on. And yeah, if I would start over, I would add verification tools much earlier than what we did when we did that. The reason it was a little delayed was that we tried to basically fully formalize the language in the beginning, which is a huge effort, and that's why we pushed it back a little. And at some point we realized that it just doesn't make sense, and then we basically started over with these formal analysis tools and just added mechanisms where you can at least do formal assertions about single functions or single blocks of code. Yeah, and another thing I would do different is probably like if you add a feature and think of a way people could abuse it, and then you think, oh yeah, that probably won't happen. I mean, people, yeah, and then yeah, it will happen, of course. And so, yeah, basically more take into account which mistakes people could make.
Would you change anything about the EVM?
Yeah, certainly, tons of things.
Like what? Like what?
32 byte types was probably not the best idea. I think the main reason to have 32 byte, how's it called? Native size, whatever, register size. I think the main argument for that was that you could do crypto more easily, and crypto stuff usually requires large numbers, and it turns out through Ethereum, through the virtual machine, through smart contracts, you can actually abstract away all the crypto stuff. So you can do this, and you don't have to know anything about crypto. I mean, you have to know about how to verify digital signatures, perhaps, but you could even go without that because the system does that for you. And I think these 32 byte types slow down the virtual machine extremely, and also bloats the blockchain and things like that.
Hi. My question is regarding competitor platforms. So there is a recent surge of Ethereum killers, so self-proclaimed Ethereum killers, Qtum and Cardano, and ignoring the price and everything, just the technology. They are young platforms who claim to fix all Ethereum's mistakes, which is, I don't know, it sounds a bit ridiculous, but I'm interested specifically in the scaling. I mean, those platforms, the main offering compared to Ethereum is that they're using now proof of stake, and Cardano, for example, boasts that their proof of stake is super legit and super verified and peer-reviewed. So my question basically is why aren't you copying them, and generally what do you think about those solutions?
Yeah, so I have a lot of opinions about these solutions for the most part because, well, firstly, like their proof of stake protocol, I mean, it has nothing at stake in long range attack problems. They have not done any of the economic work almost at all, right? They just are doing consensus protocol work, and the consensus protocol work is not even asynchronously safe. It's like partially synchronous. They have low overhead, but like so can any blockchain really. So I think their consensus protocol is like way overhyped and under, like, you know, like not actually that great. I think like EOS also consensus protocol sucks. I mean, basically you go down the list, I'm really like, I think all of their consensus protocols like are far from optimal. You know, people do accuse me of over engineering sometimes, but I think like, you know, just I can tell that they're like quite far from optimal in terms of the like consensus protocol stuff. But I think the main thing to realize about Ethereum killing is that there's a lot more to the blockchain than just the core technology, right? There's all sorts of upstream tooling. There's the community, there's the culture, there's the governance, there's like the whole raison d'etre that like brings everyone together, right? If you bring a community together to kill Ethereum, like that's like not gonna be a great community. Like, I mean, at least it does. I'm not inspired to join. Maybe because I'm conflicted out, but maybe because like it's not really like being against something and like it's not that like exciting, right? So somehow there's the community governance and tooling side that is way beyond like these technical claims that they have, and that takes years to build out, and it takes a lot of work that isn't something that like, you know, nerds can do alone in a room.
Overall, Ethereum at the end it's made about technical, about depths, about technical people, mainly in the people that's in the community, and we are not married on Ethereum. We are married in the technology. We are married in improving, in getting the things better. If any, and we are not against anybody, any chain that is trying to do the things, is trying to improve, is trying to fix, is trying to get in the things better. Great, it's perfect. We want to do that. We are all on that. We are all on that space, and this is mainly the spirit. If appears a new chain that's better than Ethereum, and we see that that's the way to go, most of the dApps in Ethereum will go there. It's about the technology, about getting better. That's very much the spirit. That's very much the spirit in Ethereum. And said that, well, if you compare right now, the only chain, this through incomplete, where you can really create dApps, smart contracts, and you can really do interesting things, that has been running for more than 2 years now. That's working quite well. That has suffered a lot of attacks. It's robust, and it's in a stage where you can really do real applications. I think that right now is Ethereum. Probably there is other ones that are still there, great, but the one that's clearly different, at least in my side, and I don't know all the space. For me is Ethereum.
Yeah, I want to say something on that too. As a dApp developer, I don't really see that distinction. It's kind of silly. That's like saying, is Android the iPhone killer? You know, if you're making apps, do you make an app just for iPhone because you're an iPhone maximalist? I mean, sure, if you don't want to get the rest of the customer base. So the whole concept seems kind of silly. I love multiple platforms. Sounds like a great idea. Next question? Tom, you got something? Oh, come on. I'm down patrolling.
Okay, I was wondering about the EVM under bad decisions. How likely would it be to fix that? And how easy would it be to fix those decisions for like a new version without breaking everything? Did you get it?
Are you
okay. I'm asking about you were talking about bad decisions in the EVM, like 32 bits types and so on. And how easy would it be to change those design decisions in the EVM to improve the EVM itself? Like how easy?
So, I mean, adding new opcodes to the EVM, that is something we do with every single hard fork, but changing these core things like the size of the values of the arguments, that probably won't happen. But what we are considering is completely replacing the virtual machine by a WebAssembly-based virtual machine, and this solves. I mean, it is a trade-off because it's not 100% in our hands, WebAssembly, but it solves lots of other problems. So we would rather go to WebAssembly than changing one of these core properties of the EVM, I guess.
Can you say something about eWASM? No? You know.
So eWASM is basically WebAssembly plus certain built-in functions to access the blockchain and interact with storage, other contracts, and so on, plus built-in resource consumption counting. So when we execute a smart contract, we always have to keep track of how many resources it consumes, so that to protect against DOS attacks and just to reward the miners properly. And for the EVM, we do that as part of the interpreter, so every single opcode has a certain cost. Some opcodes have costs that depend on the arguments or the current state. And this is a little difficult with WebAssembly because it's mainly built to be compiled. And the way it is solved there is we just take the WebAssembly code, the AST, and modify it so that it basically has a global counter which just gets incremented accordingly for every single line of code that is run, or every single instruction there. And so you can just take this modified AST, run it through any compatible WebAssembly interpreter or compiler, and get your resource counting automatically.
Hello. For this technology to really change the world, I think it has to reach people at some point. So otherwise it might end up as a corporate tool, or as a niche tool. So that I think basically that means granularity of transactions, granularity of contracts might increase substantially, and that also then raises the question of scalability. So do you think the technology is already ready for really scaling this up to a point where we really could say this is a tool which might end up thanks. This is a tool which might end up as really a game changer or changing the world in the end?
Well, scalability is a challenge. It's probably one of the biggest challenges in the blockchain space. And there's a whole bunch of different types of solutions, and there are various stages of completion. But there's kind of a couple of questions. One of them is what are the fundamental limits to how scalable this can be, and on chain, and what's the most efficient way that we can use the blockchain, right? And there's a lot of people doing work on both of these directions. I'm personally working mostly on the sharding kind of direction, and I don't yet know the limits to the scalability. But I can tell you that it's not unbounded. It's not going to scale infinitely for any given node capacity. We can only have a finite number of shards because we have to maintain consistency properties across shards, and that takes an overhead that is increasing in the number of shards. And so I think it's very unlikely that we're going to get infinite scalability on-chain. But that doesn't mean that it's not going to be much more scalable than it is today.
Besides scalability, of course I want to mention also the other 2 points for going mainstream. One is security and the other is usability, which are very related to each other. Sometimes we add here the volatility in the case of the coins, but these are probably the 4 things that needs to go in order to go mainstream. For security, it's not only about the smart contract security. It's also, for example, phishing attacks or education of the people. It's very related also to the usability part. So a lot of effort needs to be done to go mainstream. That's not only technology. It's also about education. Explain the same way that at least now maybe your mother or your grandmother brings you one day to the bank and explains you how the banks works, and you put the money and somebody trusts and all that. We need to do a little bit the same with the society and explain how to work with this the crypto, with this decentralized world. And we can take a lot of advantage of this, but there's also this social part that we need to spread to the people to show how this technology works when it's ready.
I have a kind of applications questions. Do you think it would be possible to build a cryptocurrency exchange inside of Ethereum blockchain in some way that we would not have to trust any of these like sketchy companies that run existing exchanges?
It already exists right now. It's the Delta. Delta is one, and 0x is the other one. They are more or less on chain, both of those, and well, they are not scalable. If you want to run a bot on those exchanges, probably it's not going to work very good. But it's a first step, and I'm sure that these side chains and proof of stake and all sharding, when the technology improves, this new exchange will come. Probably, I will tell you that a decentralized exchange is probably the most seen project when you go over the space. Is like I don't know, like 10 or 12 ICOs and companies that are trying to do this decentralized exchange in the space. Yeah, it works in tokens between Ethereums. Yes, this EtherDelta works in tokens between Ethereum. Yeah, but you can have like a token that represents, for example, a Bitcoin or an euro or whatever, and then it's not about exchange. It's then you just do the value converter of when you withdraw.
And a kind of thing to note about these protocols is that it's not all on chain. It's just the custody of the funds and the settlement of trades that's on chain with these two what we mentioned, and it's kind of a non-custodial exchange is one way to think about it. But there's and that technology I think is more promising in terms of having good usability quicker than a fully on-chain exchange.
Hi, I have a question. I recently was asked to review a ATM provider's backend code because he was selling Ether at an Ether ATM, kind of Bitcoin ATM, Ether ATM. And at one point, a lot of these transactions were failing. And I looked at it, and it was like, because I think it was, I'm not sure, but that's why I'm asking. There was a transaction in the mempool already for a previous customer. And then we send out the next customer, but that was not confirming because there were some transactions coming ahead of that, and we couldn't bump the fee because there seems to be no replaced by fee or something like that. And you cannot have more than one transaction in the mempool, is that correct? Or maybe I misanalyzed the situation?
I mean, I can take this one if you want. I know there's nonces. And so the first person, when an account sends a transaction, they have to be done in order. And so there's this little counter called a nonce. And if the first transaction hasn't gone through, then the future ones won't. So you can bump the fee. You can replace the transaction by sending another transaction with the same nonce as the one that's stuck. So you replace that one, and then all the rest should follow through if the gas is high enough for the miners to pick it up.
What are the use cases you guys are most excited about?
Yeah, no, I'm happy to start. I'm most excited about this use case for like international institutions and for international governance of like a middle ground, like a neutral territory that like governance institutions can use that is outside of the jurisdiction of any of the individual members. So, for example, like if we're going to have like a cap and trade for like carbon credits, having the record be not in the jurisdiction of any one of the states of the agreement, I think will make it easier to agree to, right? And so I think it'll make it a more powerful policy, right? And so I think the use of the blockchain as this kind of non-jurisdictional thing is the thing that I'm the most excited about.
Governance, of course, is one of those. There are other, for example, well, as I mentioned before, for example, all these stable coins and all this evolution of the money, it's also something that's happening that's very interesting in the blockchain. Of course, all the donations platform that we are doing, Giveth, it's also, this can change a lot. This is a good application that I'm very excited on. I don't know, there are many applications.
Yeah, these are not specific applications or use cases, but more like directions where hopefully the community will go, and I'm excited about anything that allows us to remove these pesky ads everywhere by just paying for stuff someone does for you, even if it's a tiny amount. And also removing the fact that all companies collect personal data all the time, because you can just remove this company from the transaction and directly, for tiny things, directly trade with the person you're having a relationship with.
I'm personally a big fan of autonomous devices and autonomous organizations, like self-owning cars or like self-owning IoT devices that are programmed for a special use case and they can manage themselves. And I'm also I would like to see like another use cases of decentralized autonomous organizations on the blockchain, maybe without putting too much money into it.
Something I'm also kind of excited about, but more nerdy, less exciting kind of way, is like the reduction in transaction costs by using smart contracts. Like I think that we're going to see in like industrial organization and we'll find cases where we can reduce transaction costs by using smart contracts, and I'm excited about that because transaction costs are the root of all evil. As from a Kosian point of view, he's like an economist. You should look him up.
What are the use cases for Ziki snarks in Ethereum?
I will tell you just one. He will tell the rest. But one of those is, for example, anonymous voting.
I'm not so good with use cases.
I've got a bunch. I really love partial settlement of state channels with zero knowledge proofs. So you show that I'm allowed to withdraw this money from the state channel without showing anything else and allowing the state channel to continue. Or even full settlement with zero knowledge proofs. I really love the idea of recursive zero knowledge proofs for guaranteeing the validity of blocks. So like every block header should have a zero knowledge proof that it's valid and that the previous block had a valid zero knowledge proof. So that you can verify one zero knowledge proof and know that the entire block's history is valid. Like that's magic. More generally along this lines is like the idea of like saving computational time by providing zero knowledge proofs as a concise proof that computation happened. Another thing I'm really excited about is privacy, right? I mean, we want to have like anonymous currency on the blockchain. We don't want to link all our activity via gas, right?
Perhaps, ZK snarks actually have two properties, and the first one is the zero knowledge property, that you can kind of convince someone about something without telling why it is true. And the other property is that the proof is tiny compared to the actual, compared to a computation that would verify the same thing. And you don't always need zero knowledge there, but it basically comes for free, at least for ZK Snarks. And that's why you can do something like you can verify the validity of a blockchain with just 5 cryptographic operations.
One particular application that I'm excited about is imagine a decentralized exchange or even a centralized exchange that doesn't know who's placing the orders, right? Because you produce a zero knowledge proof that you have a right to place an order, and it doesn't need to know who's matching with, because you can produce a zero knowledge proof that you've been matched when you need to withdraw. And so like that's super cool tech. There's like a distribution tech where basically you want to make a payment to of dividends or something, and if you don't want people to know how much of the share they each other have. There's all sorts of applications because privacy is a serious problem, and zero knowledge proofs are one of the easiest and most conceivably available general purpose tools that are in the pipeline.
One last question. Who wants it? I mean, we weren't trolled at all.
Yeah, let's get some
I know there's Monero guys who want to talk, like Bitcoiners. Give us something. Let us have some fun. Oh, we got one.
Thank you very much for being here. For Christmas, I give my family gift of Ether. I wanted to give them Bitcoin, but the transactions fees were too high. And right now, de facto, you are the payment network. Right now, I can see Ether becoming the payment network. The amount of transactions is through the roof. And yes, people are transacting money using Ethereum. Bitcoin is now... but yeah, I'm sorry, this should be a question. Thank you very, very much. This is amazing work.
Yeah, I think you're trolling the Bitcoiners.
I give you bad news. Bitcoin and Ethereum suffer exactly the same problem. Of course, Ethereum is newer and it's much better in that, but the essence, it's also limited. The blocks are limited. The quantity of transactions that can do Ethereum is limited. And maybe right now it's better, but this not solved. The scalability problem is not solved yet. So I'm sorry, but that's not a good news for that.
But also the governance at Ethereum hasn't committed to not solving it.
Thank you, guys. Thank you so much.
There's one last thing I want to say. So, if you got a little bit excited about Ethereum now and know a little C++ and would find it great to work full-time on an open source project, then please talk to me. We're hiring a C++ developers for Solidity.